All right, so today we're going to be talking more about dilations, but we're going to be doing it while also thinking about area. Okay, so just to remind you about what area is, okay, area is a two-dimensional way of measuring how much space a shape takes up, right? So we know that a one-dimensional way of measuring something is length. A two-dimensional way of measuring something is area, right? So a shape is going to have two different, basically, lengths. So it has this length right here, which is 3, and it has this length right here, which is 3. Okay, so we calculate things in what's called a square unit. So this right here, this is 1 square unit of whatever you're working with. So you could have square inches, square centimeters, square miles, square kilometers, whatever. So as we see here, if we draw out 3 by 3, that gives us 3 columns. There's column number 1, here's column number 2, and here is column number 3. And each column has 3 squares in it. And so in total, we have 9 squares. So we would say that this shape has an area of 9 square units, whatever that is. And the way that you can do that for a rectangle, which this is you can just multiply your length and your width together, and that gives you 9, right? So here we would have basically 7, 5, 6. We would have 7 columns, and each column would have 3 squares in it, and so 7 columns with 3 squares each would be 21 square inches. For a triangle, it's similar to a rectangle, right? Because if you think about the triangle that you have, and if you took a copy of that triangle and you rotated it around, it would actually make a rectangle, right? So if you think about this as being the rectangle, and so this rectangle would have an area of 4 times 7, which would equal 28. But that rectangle was 2 of our triangles, so we want to divide it by 2, and that gives us 14 meters squared. Okay, so the area formula for a triangle is the base times the height and then divided by 2. Okay, because a triangle is half of a rectangle. So that's just a quick review on area. Now, what we want to do is we want to look at how does the area change when we are doing dilations, okay? So we have a square here. What is the area of that square? It is 1 square unit because it just takes up, 1 box. And so we want to dilate it by a factor of 2, which means that our new square is going to look like this. All right. And so here would be A prime, B prime, C prime, and D prime. And so the question is, what is the area of our new square? So if we count, we have 1, 2, 3, 4 actual boxes here. So now it would be 4 square units, right? And so what happened, right? So what is the ratio of the area of the original square to the area of the new square, right? It's 1 to 4, okay? Or you could think about it, if you wanted to think about it, as 4 divided by 1 is 4. So our area got 4 times bigger. Now that's interesting. It got 4 times bigger, right? Because the scale factor was only 2. And we're going to try and figure out why that might be. So we're going to look at another one, and now we want to dilate it by a scale factor of 3. So now we want all of our side lengths, 1, 2, 3, to increase and get 3 times as long, okay? So what do we think that is going to happen to the area here, right? So this is the same square as we kind of looked at in the beginning. We have a 3 by 3 square. That means we have 1, 2, 3, 4, 5, 6, 7, 8, 9 squares in here. So our area is 9, and the ratio is 9/1, which equals 9. So it got 9 times bigger. So again, we have a scale factor of 3, and the area got 9 times bigger. So what is going on here, right? Let's look at another one where maybe it's shrinking, okay? So here we want to dilate it by a scale factor of 1/2. So we want to shrink everything in towards the middle, right? Now this one is a little bit interesting. You got to be careful here. You don't want to just count the squares because in order to make this shape, I had to zoom in, and that kind of affected the grid. But remember, this is still 1 and this is still 1, right? So our original square was a 1 by 1 square, so its area was 1, right? So our new square is only 1/2 by 1/2, right? So if we do length times width, 1/2 times 1/2 is 1/4. So our new square has an area of 1/4. So what is the relationship between the area of our new square to our old square? Well, now it was 1, and it was 1 and it became 1/4, so that's 1/4, right? So there was a scale factor of 1/2, but our new area was smaller by 1/4. So it seems that the area changes not in the same way that the lengths change, right? We had scale factor of 2, got 4 times bigger. Scale factor of 3, it got 9 times bigger. Scale factor of 1/2, and it divided by 4 the area. So what's happening here is that when you have a two-dimensional shape or a two-dimensional measurement, right? So let's say this is a 2 by 2 square, right? And if you want to double all of its lengths, okay, that means you're basically doubling it 2 times, right? So this length down here became 4, this length became 4, right? So how many copies of our original shape can we fit in here? Well, there's another one, and then there's 2 more over there. So this was our original shape right here. Now we have 4 of our original shapes, right? So when we doubled the sides, the area got 4 times as big because basically we had to double 2 sides. So we doubled 2 times, and 2 times 2 is 4. That's why above, when we looked at this problem, right, we tripled 2 times and we got 3 times 3 is 9. Here we cut in half 2 times, 1/2 times 1/2 is 1/4. So if you have a shape that is dilated by a scale factor of k, so if k is the scale factor, then that means the new area will be dilated by a factor of k squared, right? Because you're multiplying by k in 2 different directions, okay? So I want you to try and use that information to see if you can do 14 through 19. All right, hopefully that made sense. I'll put another video in there as well. If you want to watch that too, you can. Try and get this done, I'm sure Miss Palmer will help you, or Mrs. Gimrick or whoever if you have more questions. Good luck, and I will see you guys later.